Okay, we're in section 8. This is a lecture portion. We're going to talk through the notes, of course. It's not much, though. If you look at this, there's sort of like, it's probably like less than a page of notes for this. We'll talk through each topic, though. All right, what you need to know about this. I do want to emphasize that there's little tiny videos over here. For those students that have a tough time listening during lecture, you can always go back and look at these little spot lectures if you like, or just simply watch the lecture in its entirety by looking at the posted version of it at the end of the week. All right, but we'll go to this. So our intent is to get to the examples because that's really what we want you to be able to do is the examples that we're giving you. All right, so let's take a look. I'm going to do another share with you. Give me a minute to do so. And this will be a short lecture. Okay, so we're on polynomials. All right, it would be nice, I would say, before you come to lecture to read the material, but we're still going to go over it. All right, so it says a monomial. All right, this is an interesting concept. Poly meaning many, monomial meaning one. So what does it say a monomial? It says it could be a number, it could be a variable, or it could be a product of numbers and variables. All right, so if the variable has an exponent, it must be a non-negative integer. Let me talk about non-negative integers for you. Non-negative integers, I'll write them down for you. 0 is non-negative, 1, 2, 3. These are the non-negative integers, all right? So if there's an exponent, it's got to be one of those numbers, if there's an exponent, all right? So they give you some examples over here. And the examples they give you, 5, it's a number, right? X is just a variable. 3x squared is a product of a number and a variable raised to a power, and the power is a non-negative integer. These things over here, all right? This one over here, a number like minus 12, and then there's a variable x squared, again, a non-negative integer power, and y. By the way, the power y is 1, all right? So a polynomial, oh boy, a variable expression in which the terms are monomial. All right, let's look at that. This has two terms. The two terms are as follows: 3x. The other term is actually minus 2. The reason for that is we think of polynomials as being addition of terms. This is a polynomial. There's 3 terms there. Well, the first term, second term, third term. First term is 2x squared. It's a monomial. The second term is actually minus 3x. That's a monomial. And the last term is 4, which is also monomial. This one over here, again, it's a polynomial. There's 3 terms in it. The first term being 4xy squared. The second term being minus 7x squared y. The third term being 9xy. Each term is a monomial. This is also a polynomial. There's 3 terms in it. First term being x cubed. Next term being 2x. Last term being minus 4. All right, let's read this. It says the degree of a polynomial in one variable is the greatest exponent on the variable. Let's look at examples. This is an example right over here. I want to go through with you one step at a time. This has 1, 2, 3, 4 terms in it. The terms are as follows: minus 11x cubed, which is a monomial, 4x squared, which is a monomial, 15x, which is a monomial, and minus 9, which is a monomial. All right, so there's a polynomial expression. And someone says, what's its degree? Well, if you looked at it, you'd have to look at the variables in the problem. It's a one variable problem, x. What's the highest number for the exponent? Well, look at it. And what do you see? Well, I'm hoping you notice it's 3 over here. So it's going to be degree 3. Let me write that down for you. This is degree 3. It's a degree 3 polynomial. All right, let's go to the next one. A polynomial in one variable is usually written so the terms are listed. By the way, when we say usually, not always, all right? So this is like a usual thing. They're going to be usually written where the terms, the exponents, will go down in decreasing, all right? Decreasing degree order, all right? So for example, this one over here, we don't mind the way it's written, but it looks peculiar to some people. They write it in a decreasing order of degree. And what's the degree of this thing over here? Let me point it out to you. It's degree 3. So what do? They rewrite the polynomial. That's 3 terms. Let me point out what those 3 terms are again. The 3 terms, I'll write them down for you. One of the terms is 2x squared. The other term is minus 3x cubed. And the last term is going to be minus 9. What do? They write them in descending order. So the first term they'd write down, minus 3x cubed, then it's going to be plus 2x squared, and then plus minus 9, or simply just minus 9. It's in descending order. However, when you study math further, they're going to also write these in what's known as increasing degree. That is, they start from a small one and move their way up. All right, let me just outline that for you where you see that. And they say increasing degree. All right, so the example over here, same example, what do? Well, they start with minus 9 now. Next term would be 2x squared. And then the biggest one there is minus 3x cubed. When I say the biggest exponent, right? Simplifying still follows the same order. Now, when I say that order, it's the order you guys know about, the PEMDAS, which is parentheses, which really means grouping symbols. And the grouping symbol is going to be parentheses, square brackets, but also fraction bars, right? Fraction bars also indicate a group, all right? But for the most part, we've been doing this for some time now, right? So what do? We basically go through the order of operation, PEMDAS. Again, grouping symbols, exponents, multiplications, divisions, left to right, and then addition, subtractions, left to right, all right? It's probably well understood at this point that you've been doing this for some time, and you probably have an intuitive understanding how to do it, right? What are we doing? Basically simplifying. And if we see like terms, that's part of simplification, pull them together. So let's take a look at an example. I'm going to pull it on the side for you, and we'll go through it. Oops, I got to be a bigger than that, though. Okay, give me 1 second. Pull this on the side, and I'm going to discuss what we'd like you to do for a problem like this. All right. So the first thing we'd like you to do is just, I notice there's a lot of things going on here, and someone says, well, I'm going to rush to the end of it. I'm not in a rush, and you shouldn't be either. What you should be looking at is to remove the grouping symbols. I want to put out what I mean by that. This 2 here is distributed across these terms here, right? One at a time. So a lot of distribution, not really. Let's take a look at it. 2 times 3x squared is 6x squared. Then what do you get? Minus, you know what I should do first? I should simplify what's inside that group first. I just noticed that. Let me erase that. This is a common thing students will do. I'm going to erase all this business over here. Erase this over here. And I'm going to simplify what's inside the grouping symbol, which is probably more appropriate. Equals 2. Well, I'm going to combine like terms. What's a like term? A like term is a term. And by the way, there's 1, 2, 3, 4, 5 terms. I can put that out to you. 1, 2, 3, 4, 5 terms. Like terms are terms that have identical variable parts. Well, these 2 terms are like each other. What do? Add their coefficients. What are their coefficients? Minus 2 and 3, which would give you 1. 1 what? 1x. That means 1x. 4 minus 5, they're like terms. What do you get over there? Minus 1. Minus 3, same thing over here. I'm going to count this for you over here. 1, 2, 3, 4, 5, 6 terms. 1, 2, 3, 4, 5, 6. Like terms, x squared minus 2x squared. Combine their coefficients. 1 minus 2 is minus 1x squared. I'll just put down minus x squared. What's next up? 5x minus 9x is minus 4x. What's next? Minus 7 plus 11 is going to be plus 4. Now I'm going to use a distributive property of multiplication. I'm going to distribute across those 3 terms now. After I'm done with that, I'm actually going to take the minus 3 and distribute across these 3 terms. Let's do that. What do you get? 6x squared plus 2x minus 2. Minus 3 minus x squared is plus 3x squared. Minus 3 times minus 4x is plus 12x. Minus 3 times 4 is minus 12. All right, what I'm going to do now, combine like terms. 6x squared plus 3x squared is 9x squared. All right, let's keep going. 2x plus 12x is 14x. Let's keep going. -2 minus 12 is -14. Now, mistakes happen. What I want to encourage you to do is when mistakes happen, at least go back over and say, I wonder what went wrong. I would just do the problem over again. I wouldn't want to always go, I'd say I made a mistake somewhere. Let's take a look at the K. And what do they tell me? Let me look at it. 9x squared plus 14x minus 14. Fairly simple, all right? Fairly simple. All right, let's go to the next page. I think we're done with that. Yep, we're done with that. The next page, and we'll talk about this. All right, evaluating a polynomial for a given value of the variable. They might use notation that you might not be totally familiar with, but I hope you've seen it before, but if not, doesn't matter. I'll read it to you. And as I read it to you, I want to go through what they want you to do with this. And this notation over here says, it says F, right? And the way I'm going to read this is I'm going to say F of X is, well, it's 3x squared minus 4x plus 2. So what do they tell me over there? They're telling me that F is a function of X, all right? That's a big concept. But what they want you to do is they want you to evaluate the function F for a particular value of a variable X. So they want you to do F of minus 2. Now, we're going to recommend a particular way of doing it. And again, you might say, so well, I can do this really quickly. I don't need to do this, what you're doing. We don't say you need to, but some students make mistakes over here. Let's go through what we want you to do. Well, I'm going to write this down. F of X, what's X? Minus 2. Again, I'm looking at this over here. What I recommend you do is parenthesize the variable in the problem. And I'll do that right now. So 3, there's a variable here, squared, minus 4, a variable plus 2. That's the first thing I'd recommend you do. The next thing I'd recommend you do is just plug in the value of that variable, and that's minus 2. Now I'm going to do the arithmetic. This is going to give me 3. Well, minus 2 squared is 4. I think I can do the next one. Seems pretty easy to me. 4 times minus 2. That's going to be minus 8, but minus 8 is plus 8. 3 times 4 is 12. Again, we're not saying you have to go all these steps over here, but we need to agree upon the answer. And 12 plus 8 is 20, and 20 plus 2 is 22. Again, we do give you answers, and I want to make sure you know you're looking at those answers that we give you, and you need to be agreeing with those answers. All right, so we'll start doing examples. But again, when I say we do examples, the point of the examples is to illustrate what we just spoke through. All right, thank you.